588 cubic inch Chevrolet Marine motor under certain aspects of assembly. The shot is included to show the valley screen we use on the big block Chevrolet in an attempt to prevent any debris or stray material that may find its way into the motor due to rocker arm or pushrod failure. Due to the large oil drain back slots directly over the camshaft, any of this debris that falls down out of the cam can turn into a major problem, whereas this screen allows the material to be caught and prevent camshaft and lifter failure. It's just an attempt to show the dome configuration of these pistons. The compression ratio of this motor being in the neighborhood of 9 1/4 to 1. The piston has a distinct dish shape with a small band around the circumference that acts to create a bit of turbulence in the combustion chamber area. This particular motor also has a cam-driven water pump installed, which is an extremely good idea, considering the fact that water pump impeller failure does occur, particularly when seaweed or whatever is sucked up into the water pickups. And when you starve the impeller for water, it is very possible that it will fragment under the heat. This makes an impeller change a 5-minute job in a very accessible location out of the water pump and its cover. This particular motor are the Chevrolet bow tie offering. Extensive port work has been done on these heads, as have combustion chamber work and a 3-angle valve job. These heads flow extremely well. When tested on a Superflow flow bench, pitted against offerings from Valley Head Service or Airflow Research, they have shown superior flow ratings at all valve lifts. This particular shot illustrates the stud girdle that is used to tie all of the rocker studs into each other to provide some rigidity so that any harmonics that develop due to the RPM range involved or whatever don't affect any one particular rocker stud. Rocker studs have been known to break, and this is one method that's used to give just a little bit more accurate valve timing or dependability to the valve train of the big block Chevrolet. This shot illustrates the insertion of slugs of tungsten, a heavy metal, used to add enough weight to the counterweights so that this long stroker can be internally balanced. All the machine work on this particular motor, or pair of motors, was performed by myself while I was employed by Miles Engineering in Cleveland, Ohio. I worked for Gary for 4 years and learned a lot, particularly in regard to building durable big block Chevys, as his main product is a very well assembled and race winning 468 cubic inch big block offering. particular shot is an attempt to show how vastly the block had to be relieved in the oil pan rail area for this large stroke to be accommodated. This is a corresponding shot of the full-length windage tray I constructed to complement this particular pan style. This motor runs an external wet sump pump, and for that reason the tray can extend all the way to the rear of the pan, since the pump is no longer in place to restrict the stage Aviad external oil pump. The beauty of this system is that if there are ever any pump malfunctions or the pressure is not quite suitable, the adjustments and or repair can be made in a matter of minutes, as opposed to pulling the motor, pulling the oil pan, and going through all that rigmarole to work on a $40 oil pump that really has no business in a $20,000 to $30,000 motor.
By selling real estate.
Choice.